Hello everyone. Today I will explain the assignment 5 and the next. Let's start our loading our file and this is our data. It's about the weather data and first of all we do some cleaning and pre-processing. We drop these unnecessary columns and convert the units. For example, here we can see that we convert Fahrenheit for Celsius for like also for pressure, for MBR, and for wind also. This is our like final data frame with date, average humidity, maximum humidity, minimum humidity, average temperature, maximum temperature, also average pressure, maximum pressure, also and the average wind and the maximum wind. There is a no null values and also this is about info about this data set and there is a no duplicated sum and this is a statistical summary statistics for the data hour. Let's start. Let's move the next task is a time series analysis. We choose this column for analysis average temperature, and there is a our visually like we plot them daily average temperature, and the next task is like apply decomposition for uh, like strength, seasonality, and the residuals. And the first one is original one, and the next is like visually trend our how we can see, and the next one is seasonality, and the last one is residuals. We can see them visually, and we the next task is build a fit the ETS model. Uh, we give them some parameters and with seasonal periods 365 and we forecast for next 20 days 30 days and there is this one and here we see our visually this is blue one is actual and the red one is like predicted it is forecast predicted and the next model is the ARIMA model. Here we like forecast for 30 days, and we give also we like forecast for 30 days, and we see them visually. This is also like predicted ARIMA forecast, or green one. The next task like is just we evaluate like our models. This is AC for ETS and the ERIMA, MCA, MEA. And how you can see there is a MCA like very good results for both one. The next task is predictive analytics. We first of all we create like our features, also target variable, which is a temperature label, and we calculate them by like for finding median for average temperature. And if you use more than like this median, we like give us as a like true or like otherwise like false. We do some standard scalar and we apply like do trains test splitting and apply the like elbow method for like this Canadian classification, our Canadian classification. And for visually, we choose the best K elbow method. How we can see there is a five, and we choose a five. The next task is like if we can see the accuracy for Canadian classification, and the next task is like linear regression with the same features, with same target. Also, we do train splitting and feed them linear regression, and we predict. This is our like evaluation, our like linear regression, MCA, RMCA, and MEA. This is all also very good results for our model. The next one examples of two sample observations. We first of all will give the uh, first sample and the next like sample like and we predict them using the linear regression and Canadian classification. This is our first sample with the linear regression prediction and the classification with KNN. This is our outputs and the results report results for like sample observations. The next class task is a visualization and reporting. For here we visually shows the displays the like ETS versus ARIMA forecast comparison, also for linear regression and Canadian classification. How you can see there is like our visually like for forecast comparison for ETS and ARIMA. And this is for linear regression, actual like predicted values for linear regression. The next one is for Kininian classification also. The next task is a rigid plots for ETS, ARIMA, linear regression, Kininian classification. First of all, we do for ETS residuals, ARIMA residuals, and for linear regression. This is our like outputs for Kininian classification. Also, we have. And the last one is model performance, like performance table. We calculate for um, all of them, and how we can see there is an output for ETS, RM, and linear regression, also Kenyan classification. By this output, we can say that there is ARIMA is more gives for us like more better results than ETS with like MCA, MA, and RMCA. Also for linear regression, ETS, and the last one like Kenyan classification matrix with accuracy is this one. This is all. Thank you for your attention. Goodbye.